Welcome to another coding tutorial, and in today's video, I'm going to show you how to make this cool looping animation. The shape looks kind of complicated, but actually it is quite simple. Let's start by creating a grid of 3 by 3. I'm going to use a nested for loop that goes from I equals to 0 to I less than 3, I plus plus, and then the inner loop will be from j equals to 0, j less than 3, j plus plus. And then let's draw a rectangle from I times size, j times size, and then size and size. And we also need to define what size is, which is going to be the width divided by 3. All right, let's run. Next, I want to draw 4 circles, and these 4 circles will have the center at this point here, this point, this point, and this point. So it's all the corners of the middle square. And how we draw a rectangle in p5.js, we define it by the x and y point at the top left corner of that rectangle, right? These are the top left corner of this square, this square, this square, and this square. Let's draw the first circle. I'm going to use an ellipse function, which takes in a total of 4 arguments. The first 2 are the x and y coordinates of the center of the circle, and then the third and the fourth are the width and the height, or the diameter of the circle. So we know that for the first circle that I want to draw here, the x and y coordinate is the top left corner of this square here, which has I equals to 1 and j equals to 1. So basically I'm going to do I times size and j times size. So it's going to be 1 times size and 1 times size. And then how about we give the circle size of, let's also define that. So the diameter, let's set it to, how about 100. So d, comma d. All right, and I'm going to draw 3 more. And then it's going to be here, which I is going to be 2, and then j is going to be 1, right? And then for this one, it's going to be 1, and then 2, and then the last one, which is this one, it's going to be 2 and 2. Perfect. And then let's do no fill. But we don't actually want a circle. We want an arc. And we can use an arc function within p5.js, which takes in a total of 6 arguments. The first 4 are the same arguments as the ones that we already put inside the ellipse function. Then we need 2 more, which is the angle at which we want to start the arc and end the arc. So I'm going to use all the angles in degrees. So let's first set the angle mode inside setup to be degrees. And then if we change this to arc, and then the first one, which is this one, right? I want to draw the arc from angle equals to 0 to angle equals to 90. So basically I just need to put in 0 and 90 here. Let's click run. All right. And then for this one, it's going to be arc from angle 90 to 180. All right, and then the third one will be from 270 to 360. And the last one will be from 180 to 270. Okay. We're not done yet. We actually need another set of these 4 arcs. So I'm going to copy and paste this here. And how about we change this name from d to d underscore in for the diameter of the inner arcs. And then let's do one more. Let's call it d underscore out. And then let's set it to, how about 200. And so we need to change all of these to d underscore in. And then this will be out. All right, let's run. And there you go. All right, so now we also want to move this arc to get that cool animation. And all we need to do is, how about we set an angle and initialize it at 0. And then we just add this angle to the starting and the ending angle of this arc. So basically you just need to copy and paste all of this into here. This is a little bit tedious.
A few moments later.
And once you're done, all we need to do now is increment the angle by, how about 1? So that's 1 degree at a time. And we get this cool looping animation. Let's put all of these in a class. So let's come to this arrow here, clicks the plus sign, clicks create file. How about we call it shape.js? Before we start writing a class, let's go to index.html and then come to this line of code, copy and paste, change the word sketch to the name of your new file. So it's going to be shape.js. And this is how you integrate a new JavaScript file into your program. Let's go back to shape.js. We're going to start writing a class called shape. I'm going to define 2 functions, the constructor function and display. Actually 3. I'm going to call another one move. Let's go to sketch.js. First, we're going to copy all of these variables and put it inside our constructor function. All right, so this dot size will be equals to size, and then we can just put this as a parameter. All of these will be our parameters inside this constructor function. And I think angle, we can just start it at 0. So d comma underscore in, d underscore out. And then for display, we need to copy all of this. All right. And actually, angle will be inside the move function. Okay, so actually we need this dot for all of these. So I'm going to do it by using this find function. So let's put size, and then we're going to replace it by this dot size for all. Okay, we'll come back and fix these later. And then for d underscore in will be this dot d underscore in, replace all. And then d underscore out is the same thing. And don't forget angle to be this dot angle. All right, and now inside the display and move methods, all of it are changed correctly. Then now we just need to fix these, put it back to what it was before. All right. Okay, let's try to create this one of these shapes. So let S be a new shape object. So we need 3 arguments, size, d in, and d out. Okay. All right, so size has to be width divided by 3, right? And then d in, let's do 100 and then 200. And then we call those methods. So s dot display run, okay, and then s dot move. All right, okay, code's still working. Now I want to draw a grid of these shapes, so we're gonna change this to shapes array, and then let's define columns. I want to do a 3x3 grid, so 3 columns and 3 rows. But now actually let's do grid size and calculate grid size to be width divided by actually columns. And now we need to use a nested for loop to create a bunch of shape objects. Inside the outer loop here, we first need to populate this shapes array with empty 1D arrays, And then inside here, this is where we're going to create these new shape objects. All right, so a few things we need to tweak. First, because we're creating a grid of these shapes, we need to give it an x and y coordinate of where each of the shape going to be. So we need to go back to shape.js and define two more parameters, x and y. This dot x and then equals to x, and then this dot y equals to y. And in display, we're going to translate each of the shape object to this point. So this dot x and this dot y. And by using this translate function or any transformation functions, we need to think about whether we want to use the push and pop functions, which will save our transformations and then return it back to its original settings before you call it again. And in our case, we want to do that. So we need to wrap our transformation functions around with push, and then we put pop at the end here. So by doing this, it's basically translate each of the shape to this point, and then it returns it back with the pop function before it gets called again inside that nested for loop we just created. So with this, now we need to first give it the x and y arguments, which is going to be I times grid size, right? Grid size is different from the size of the shape. So grid size, so I times grid size, and then j times grid size. And then this size here is going to be grid size divided by 3, right? Because in each of the grid, we want to slice it into 3 by 3. All right, and then we will need to tweak the diameter size here, but let's leave it as this for now. And then now we need to call display and move on all of the objects. So let's just copy this nested loop. And then we want to call display. Let's try that first. Okay. All right, so this is where we want to change. How about we do dn to be equals to 50 and d out to be equals to 70. Let's see if that would work. Okay, that looks good. And then let's do shapes of I and j. Then let's call the move function. And there you go. Looks cool. Let's change the colors and the stroke size and colors and things like that. First, I want to, so this one is for the inner ring. I want it to have, actually I want no fill for the outer one. I actually want to fill it with some color for the inner one. How about, let's do red just to see what happens. Okay, and then let's set the stroke weight to be the size 4. Okay, and then the stroke color to be, all right. And actually I don't want it to be red. I'm going to give it a new variable here, this.c, and let's set this.c as a new parameter here. From the original animation, actually the color for each shape is different, but different how? Inside here, I'm going to write an if statement that says if I plus j mod 2 equals to 0, then I want to set it to create this here, else, then I want to create this. Then let's set the color to, let's do red, and how about blue? Okay, let me explain what this is. So this expression here is called modulo, and modulo basically returns the remainder of this division calculation. So for example, if I have a number 3 divided by 2 has a remainder of 1. So this condition is false. While if I divide 2 by 2 and it has a remainder of 0, then this condition is true. So basically, when you use this mod expression and divide something by 2, if the return result is 0, meaning that this expression or this number here is even. And on the other hand, if the expression returns false, then that means whatever this number is, it is odd. So we can use something mod2 to see whether the value is odd or even. So if I click run, actually I'm gonna stop it from moving. You can see that the color alternates, right? And basically, I plus j allows us to do that. So this square here, I plus j equals to 0 because I equals to 0 and j equals to 0. And these two squares here, I plus j equals to 1 because this one, I equals to 1 and j equals to 0, and this one, j equals to 1 and I equals to 0. Whereas this one, I plus j equals to 2, and then this one, I plus j equals to 3, and so on. And by using I plus j mod 2, we can get a diagonal pattern that you can see here. But actually, the colors that I want is not red and blue. I want this color and this color. Ta-da! And I also want to change this to 40. Okay, that looks nicer. And I also now don't want to display the rectangle. So let's go back to shape.js and then let's just comment these out. And then how about we just move it again? All right. And that looks pretty cool already, but let's make it even cooler by changing the speed at which it moves. And we can do that by using easing functions. And an easing function is a function that represents the rate at which a value is changed from one point to another. And from the animation that you see here, we're changing that rate by a constant speed. And that's exactly what we're doing in this move method, right? We're incrementing everything by 1 degree at a time. And we're doing it in a very simple way because we're adding this .angle variable by 1. Alternatively, we can actually use linear interpolation equation to actually get a constant movement instead of adding it this way. And the equation is y equals to min, or the starting point, plus the amount of interpolation times max subtracted by min. So max is the ending point and then min is the starting point. For example, if you want to interpolate between point 0 and point 100, and the amount of interpolation, which is between 0 and 1, is 0.5. So you get a return result of 50, right? Because min is 0 and max is 100, and you interpolate 50%. And this min variable here comes useful when we want to interpolate a point that doesn't start at 0. For example, if we want to interpolate between point 100 to 200, right? And the amount of interpolation is 50 or 50%. So 50% times max, which is 200 minus 100, is 100. So it's 50. And min is 100. So the point that is returned will be 150. All right. And so we want to interpolate between angle 0, which is the starting angle or min, to angle 360. So basically, with this equation, it's going to be this .angle equals to 0 plus the amount of interpolation, we'll come back to that, times max, which is 360 or 1 revolution, minus min. And with this, we can subtract this 0 out, and it's going to just be amount times 360. Right? And this amount here is the amount that we need to increment from 0 to 1. So how about we set this .amt to be 0, and then what we need is we need to increment this amount by, how about 0.01. And we get a constant speed as if we were to just add it by a constant speed of 1. But now, what we want to do is that we want to give it different easing functions that doesn't move things in a linear way. You can find easing functions in many places. One of the places is this website here called easings.net, which has a bunch of easing functions. So if you look at all of these graphs here, none of them are linear, right? So for example, easing quad, if you look at the thing on the right here, it starts out slow and then it speeds up towards the end. And that is because this function is a quadratic equation. So if you click in here, you can see that the functions is y equals to x squared. For a linear function, it's y equals to x. This one is y equals to x squared. And it allows us to do that cool movement where it starts out slow and then it ends fast. And you can see that there are a bunch of these equations that you can just look and play around with. And now what we need to know is that we need to know how to use those easing functions in our sketch. So actually, I have put together these set of easing functions in a JavaScript file, so you can check out my code afterwards. All you need to do is you need to come to this arrow here, click the plus sign, click create file. Let's call the file name easing.js, which is the name that I created. And then you can copy and paste the easing functions that I have already created. And these are from the website that I just showed. You can find other easing functions from other websites, or you can come up with your own. Then all you need to do is first go to index.html file. You want to make sure that you integrate it into your program, and then change this name to easing.js. And then once you come to shape.js again, then you come to the move method. What you need to do is that you need to first write the name of the function, and then you want to provide this .amt, which ranges between 0 and 1, right, inside this function. So basically, it's going to return the y value of that equation, that easing function. And if you do this and you click run, so it goes super fast. It was fine when we used the linear function, but with the other easing functions, you need to write the if statement that says if this .amt is more than 1, then you want to set this .amt to 0, else you want to increment it. So you want to reset the amount of interpolation every single time it goes from 0 to 1. And if we do this, all right, then now we have this cool easing motion. So why don't we try a different one? Let's do, how about ease in out bounds? What is this one? That one's kind of cool. It's quite playful. Play around with these different easing functions to get a cool transition between frames. Give this one a try.